Hi, so in this video we're going to look at food batteries, and we're going to start with some demonstrations of some fruit batteries in the following videos. Measure the voltage produced by a strawberry. So I'm going to insert a copper wire on one side and a zinc screw on the other side, and connect the screws to these electrodes, and then we're going to measure the voltage, and we see that the voltage is 0.97 volt. And now I'm going to measure the current as a function of voltage using this MATLAB program, which I'm going to start now. And here you see the voltage sweeping up, and we see the current is not zero, it's -1 because the voltage is not quite zero. And then once the current is at zero, it will tell us what is the voltage produced at zero current, and we'll see what that is very soon. So now we're almost reaching zero current now, and then indeed we get a voltage which is about 0.9 volt as we measured before. Now we want to let the voltage sweep up all the way to 1.5 volt, where in this case right now we are essentially charging the strawberry battery, and now we're going back down in voltage, and we see that the current is slightly lower than while we were sweeping in the positive direction, but we still get roughly 1 volt at zero current. Now we're going all the way down. We're going to go all the way down to minus 1.5 volt, and see. And then essentially, what happens now is that we're draining current out of the battery by going to negative voltages, and so we're discharging our strawberry battery, and we'll go all the way down to minus 1.5. Once we reach minus 1.5 volt, we're going to let the voltage go up again all the way to zero and see what kind of current we're going to get at 0 volts. So now it's going to go up again, and as before we see that the current we measure is not quite the same on when we go in the positive direction in the voltage sweep. It's because we have drained actually some of the charges out by discharging it by going to negative voltages, and then we're going to go all the way to 0 volt, and we see there's a big mismatch between the first trace and now the second trace after discharging our strawberry battery. And here we go, and here we stop at 0 volt, and we measure a current of roughly minus 1.10 to the minus 4 amps, which is quite a small current. I'm going to measure the voltage produced by an apple, so I'm going to insert a zinc screw on one side, and then a piece of a copper wire, thick copper wire on close by, and then I'm going to attach an electrode on each of these metals, and then I can measure the voltage it produced, and it produced roughly 1 volt. And now I'm going to see at what is the voltage as a function of current using this simple MATLAB program. So let me start the program, and it will basically measure the current while imposing the voltage, which is called an IV. So we see now the voltage is sweeping upwards, and an important measurement will be when the current is zero, what voltage we're going to obtain, and it should be close to what we've seen when we first measured it. So it's soon going to be zero current, and indeed at zero current we get roughly 1 volt. So it's consistent with what we measured at the beginning. we're going to continue increasing the voltage all the way up to 1.5 volt. In this case, we're actually charging our Apple. And now we're going down, and we're going to see what at zero current what kind of voltage we get, and we see that the voltage is going to be slightly higher, but not much. It's very similar on the downturn for the Apple. And then we're going to go all the way down to negative voltages. What's happening right now is that we're actually draining the battery, so we're taking current out of the battery by going to negative or to zero voltage. We're basically draining the current, and then it's even worse when you go to negative voltages. So we're going to go all the way down to minus 1.5 volt. So we are heavily draining our Apple battery. Now we reached minus 1.5 volt, and we're going to go back to 0 volt. And while we have drained our Apple a little bit from its charges, so we expect the current we get at 0 volt to be less than when we started at 0 volt. And indeed, we see that current we measure slightly, the blue trace is slightly above the red trace before we hit again our 0 voltage from the start. We have 3 fruit batteries, 1 banana, 1 strawberry, and 1 apple. So we're going to measure the voltage produced by each of them. So let's first connect the electrodes to the metal in the banana, and what we see, we get a voltage of roughly 0.85 volts. So now let's put the electrodes to the strawberry, and the voltage we get for the strawberry is about 0.98 volts. So now let's measure the apple, and what we get for the apple is gonna be a little more, almost 0.99 volts. Okay, so these are 3 fruit batteries, and other batteries are definitely possible. Other fruits would work similarly. Okay, so now let's look at how these actually batteries work. And so we're going to go back to the data, and what we did is we basically took the current as a function of voltage, and we started at 0 volts, and then we went down from the high voltage down to the negative voltage, and then back to 0. And so we made a loop from 0 volts to 0 volt by going to plus minus 1.5 volt. So the first thing we can see is that there's a linear dependence between the current and the voltage. And so we can write the current as proportional to the voltage divided by some resistance, and that resistance is what we call the internal resistance of the battery. And pretty much any battery will have an internal resistance, and you can measure that by doing this what you call an IV, current voltage characteristic. Okay, so let's see now other important quantities. Maybe the most important one is typically when you have a battery and you're going to measure if it's still okay, then what you do is you're going to put a voltmeter around the 2 electrodes, and but you're not driving any current out of the battery, and so the current is going to be 0, and you're looking at what voltage it produces, and in this case it produces a voltage of about 1 volt. This was for the case of the Apple. And so the output at 0 current in this case is 1 volt. So that's typically, you would call that then a 1 volt battery. So the next important quantity is the maximum current which the battery can output. And so for this, you look at the zero voltage case, because that corresponds to shorting the battery with some wire together. And then you can measure the output current, and what you get in this battery made out of Apple was something like 0.1 milliamps. So to compare that, that's not a very big number. And let's say if you take a AAA battery, typically this output current would be of the order of 10 milliamps, so about 100 times larger. So we can already see that, that's one limitation of these fruit batteries, that the amount of current you can generate is actually not very high. So it's sometimes hard to even light on a simple small light. It would have to light on for, starting at that sort of these small values of current. Okay, so what you can also look at is now the how it actually works. And the reason you have a current generated is because you have two different metals attached. So in this case, I'm using the case of a lemon battery, but that's true for almost any fruit. And so what the fruit provides is basically a liquid with some acid in there. And in this liquid we have, in our case, the screw was was made out of zinc, and the wire out of copper. And what happens is that you're going to have current flowing from the copper to the zinc, which means that the electrons will actually flow from the anode to the cathode, while what happens with the ions in the liquid, you're going to have these positive ions which will flow from the zinc to the copper too. And so since the electrons is a positive current, the current actually is going to flow. I'm going to draw this in a different color. So the current, electrons flowing to the right, will induce a current flowing to the left. This is by definition of a current. It's always the flow of the equivalent positive charges. So when the negative charge flows to the right, then the positive charges would flow to the left. But on the bottom in the liquid, it's the positive charges, so it's going to be the positive ions. And so what you have is this loop of current flowing in this circuit. So in the liquid, it's the positive ions, and in the wires, it's going to be the negative electrons. And the reactions which generate these charges is basically, on one side you have the oxidation process, where the zinc will produce one positive ion and also two electrons. And then these electrons will flow in the wire, while the ions will flow in the liquid. And on the other side, you have the copper. And the reason, and in this liquid, you're going to have acids and so on, and that's why you have some hydrogen also. And what happens is that this hydrogen will lead to a reduction on the copper. And so the reduction reaction is the hydrogen plus some electron will create a hydrogen gas. And so you're going to have a little bit of hydrogen gas flowing out of of that battery. And that's pretty much the mechanism of these fruit batteries. And it doesn't really matter if it's a lemon or an apple or a banana. They all work in a quite similar way. And in fact, the very first battery, which is due by Volta about more than actually 200 years ago, had a very similar design. He also used two different metals, zinc and copper, the same we use for our fruit batteries, and basically connected. But what was interesting is that what he thought was the main mechanism is actually the connection between these two metals. So and that's actually true too. So if you put these two metals together, you're going to create a voltage between the two sides, between across the junction. But that's not a very powerful battery. It will create some voltage. And so in order to increase the amount of volts, he basically connected many of these junctions together. And in order to make it efficient, he also added sort of an electrolyte in order to allow the current flow through the entire battery. And so the design again is pretty much the same as the fruit batteries we looked at, and it works, it works quite well. And but the modern version of a battery is actually slightly different, because the efficiency of these old designs is not actually very high. So yeah, the modern version of a battery is based on the lithium-ion battery. And so what we have in this battery is that we, on one side, on the cathode side, we have a lithium metal oxide, while the anode is just graphite. And both are quite good conductors. And what replaces the ions in sort of the fruit batteries are these lithium ions. And so they basically move when you want to obtain current. So the electrons will flow sort of in this direction, while the ions will flow from the lithium to the graphite. And then when you're charging the battery, then you reverse the process. So in this case, the electrons will then flow in this direction, and the ions will go back from the graphite to the lithium metal. And and that's essentially a much more efficient battery, which is used in a lot of devices. Okay, so that's sort of all about batteries and fruits, and also more general. And I hope you enjoyed the video, and thanks for watching.